Ever wondered why you jerk forward when a car suddenly stops? It's not some strange spell or unseen force, but a fundamental principle of physics at play. This principle, my friends, is known as inertia. What's inertia, you ask? It's the tendency of an object to resist changes in its motion. Let's take our car scenario. You're cruising down the highway, singing along to your favorite tune. Suddenly, the car comes to a halt, but you, or rather your body, wants to keep moving. Why? That's inertia for you. Your body, in motion, wants to stay in motion. It resists the sudden change, which is why you jerk forward. This isn't some obscure science trivia. It's a fundamental law of motion that Sir Isaac Newton figured out centuries ago. So, the next time you jerk forward in a car, remember it's just your body demonstrating Newton's first law of motion. Have you ever noticed how much harder you have to push a heavy shopping cart compared to a light one? This is a perfect real-world example of Newton's second law of motion. Force equals mass times acceleration, or F equals sine ma for short. Let's break it down. When you push a shopping cart, you're applying a force to it. Now, if the cart is light, it's easy to accelerate it, isn't it? That's because it has less mass, so it requires less force to get moving. On the other hand, a heavy shopping cart, filled to the brim with groceries, well, that's a different story. It has more mass and therefore requires more force to achieve the same acceleration. Simply put, the heavier the object, the more force you need to make it move or speed up. So, when you're struggling to push that heavy shopping cart, remember you're experiencing Newton's second law of motion. Ever noticed how you move backwards when you release air from an inflated balloon? This is a perfect demonstration of Newton's third law of motion, stating that for every action, there's an equal and opposite reaction. Consider the inflated balloon. When you release the air, it zooms off in the opposite direction. Here's why. The force exerted by the air rushing out of the balloon is the action. The balloon moving in the opposite direction is the reaction. It's a fascinating push and pull dynamic that governs our world. From the flight of birds to the propulsion of rockets, it's all about balance. The universe, in its infinite wisdom, ensures that no force goes uncountered. So, the next time you see a balloon zooming around after being released, remember that's not just a party trick. It's a fundamental principle of physics. That's Newton's third law of motion in action. So, what have we learned today? We've unraveled the essence of Newton's three laws of motion. First, inertia, the laziest law, where objects prefer their state of rest or uniform motion. Then, we delved into the correlation of force and acceleration, which showed us how a push or pull can speed things up or slow them down. Lastly, we looked at action and reaction, proving that every action truly does have an equal and opposite reaction. Remember, the world around us is a playground of physics, and Newton's laws of motion are the rules of the game.